Hi, Clay Daniel with Claiborne LSAT, back with part 2 of our Intro to Logic Games and using loose sequencing video explainer. So let's take a look at how the setup process that we used, in which we set up this web of relationships that you see at the bottom of the page and considered the first and last positions and their limitations, will pay off as we go to the questions. Notice that we inferred that only I or L could be in spot number 8. That's going to help us down the road. But as you approach the questions, I'm going to recommend a particular order in which you'll take the questions. We'll see that in a moment when we choose to skip a question. But don't skip number 1, because number 1 is virtually always, at least 3 out of the 4 times in a logic game section, a straightforward, very predictable kind of question. It can be called the possibility question. It usually has the word could in it. It's done best by elimination. But the best way to eliminate is not by going through the choices in order, but rather by going through the rules in order. So let's take a look at number 1. I'm going to take a little space here at the bottom of the page just to illustrate. Let's say you were to use your scratch paper for elimination. We write out A, B, C, D, E. But let's look at the rules one by one. And we're going to expect that either all or most of them is going to knock out one wrong answer apiece. Let's start with rule number 1. And again, we're just going back and reading it on the screen. K and P are opened before H. So now we scan down the choices for question number 1. Are there any where both K and P, or I should say one of K or P, fails to be before H? As you look down, you realize, no, this rule doesn't apply here. It doesn't knock out any of the answers. In all 5 of them, K and P, in some order, are successfully before H. So we move on. Rule number 2 gave us that H, then O, then L orientation to the players. Do any of the choices fail that? Yes, indeed. Choice B does not have H, O, L. Rather, it goes L, then H, then O. As we continue down the rules, it says that L is after G, or G before L. That's violated by choice D. N is open before H, is violated by choice C. And I opened after K is violated by choice A. Looks like the answer is E for number 1. Now we shouldn't be surprised in retrospect that the first rule actually didn't apply, because there were 5 rules, but only 4 wrong answers. So if we're going to have this one-to-one correspondence, one of the rules is likely to be irrelevant. Notice how predictably, though, the other 4 rules each knocked out a wrong answer. Now, if you have any doubt about your answer here, you can use your prior work, your setup work, to support your answer, because you might be wondering, well, when do I use the web and the first, last, and all the inferences that I made? And the answer is you'll use them for all the other questions. But you can even use them here to really as a confirming mechanism. Choice E spells the word king and then has P-H-O-L. If you feel you have time and or want to confirm your answer because you're uncertain, you can look at the web quickly and see if anything seems out of line with that. K before I, that's okay. We know I could float to the beginning and be before N, which could be before G, and then we see that P-H-O-L right in order. You see how choice E makes a lot of sense in light of the web that we've drawn? So that's a great way to use your web as a confirming mechanism for number 1. But you really can, in almost every case, every opening question, use this predictable method of going through the rules. Now here's where we skip a question. We're going to go to number 3 because the conditional questions, the ones that start with if, are the best ones to address next. Why is that? Well, they give us more information, for one thing. We have another basically a rule that applies to this particular question. So more information to consider. And then secondly, if we do them first, the inferences, the possibilities that we draw from working on the if questions, the conditional ones, will help us later when we get to the so-called global questions, the ones that don't have if at the front. So in sum, go to the conditional questions after you do number 1, and here, at long last, you'll see why we have these columns. We're now going to draw one or more examples for each of the conditional questions, starting with number 3. We're going to put in the new information given in number 3, and then see what inferences we can draw from there. Number 3 says that I is second. Notice that once we put that in, we're kind of thrown back into that holistic process of combining and inferring what may come from that. We ask ourselves, what do we know about I? If we look on the page, we can see I in 2 places. We can see at the bottom of the page in the web. That's going to tell us that K must go first in this case, since K is before I. But don't forget, we also see it above column 8. And so if I is not in column 8, then L must be. It's the only other option. Now, if this were an easier question, we might get lucky and already have the answer. Maybe something about L or about the 8th position, something like that. We'll find that's not the case. We'll address that in a moment. But first, look at the wording at the end of the question. Let's talk for a moment about the kinds of questions you'll see on LSAT logic games. They essentially boil down to one of 2 major possibilities, that of could and must, possibility or certainty. But there's all kinds of variations in the ways that those can be worded, and there's also the fact that there's true and false. So to say something could be true is not the same as what could be false, and of course must be true and must be false are opposites. So what do we have in this case? Could be true except. Although it looks like a could question, it's actually a must question in disguise. Because the opposite of could be true is must be false. Because of that word except, we want something that cannot be true for number 3. It would be nice if valve number 1 or number 8 were mentioned here, or K or L, but no such luck. We don't get any of those players or places mentioned. So at this point, are we kind of just thrown into taking the choices one by one and testing them? I still think we have a strategy at our disposal, and that's to return to the concept of the star player. Remember who's limited, because limitations bring the certainties that we're looking for in a question like this. We said that H was our star player as we set up this game. And so now let's begin with a choice that has H in it. Let's suppose that H were the 4th valve. We could maybe just put it in parentheses as a possibility. Sorry for that poorly written H there. What if H is 4th? Well, in that case, what would happen? We know that K, P, and N have to be before H. Whoops. K's in front of it, but there wouldn't be enough room for both P and N because only spot number 3 remains open before spot number 4. We find that is in fact impossible, no H there, and we found our answer. We found our impossibility. Going with the star player and jumping to choice B may not always give you the right answer, but it's much more likely to do so than simply randomly going through the choices. Always look for limitation. That is the key on logic games. Where are players restricted to only one or a few spots? If you go to those places, you will be able to mine them for gold. That will make you rich as you do your logic games. All right, so let's continue with our conditional questions. Number 4 says that L is the 7th valve opened. Now, as you look at the web at the bottom, you might be thinking, there's a lot going on to the left of L. And it's true, we probably don't want to try to put in place all of the possibilities to the left of L. But remember our first and last scenario. If L is not last, then I must be. Whenever you make an inference, it's worth looking at the choices, especially in a must question. And this is another must question in disguise because it says, could be the second valve except. We want the one who cannot be the second valve, and we already know it's I because we drew that inference about the last position. So, sorry, we'll put that this one. First one was answer B, and number 4 is also answer B. And we're ready to continue. We're going to skip over number 5 and hit number 6. It says that K is 4th. Now this is going to take a little bit more thinking because it's not as helpful when you put something in the middle. Right? We like things around the edges where there's the limitation of extremes, 1 or 8, kind of things ending there. If you put K in the middle, there's a lot to think about. There's 3 spaces before, there's 4 spaces after. But look at your web. Ask yourself where the limitation is. We don't know that anybody must be before K, but we certainly know players who must be after K. Let's enumerate those. I, H, and keep following the lines, O, and L. We just mentioned 4 players, and how many spaces did we say are after K? That's right, there's exactly 4 spaces for 4 players. So even though we don't know the exact order, we do know the 4 players that go after K. I'm going to put them here in kind of a big parenthesis, or maybe we'll circle it. We want to retain the HOL order, but I is really free to go wherever. You just sort of say, in these spots 5 through 8, it's HOL. We know it's that order, and then it's I could be 5, 6, 7, or 8. But if that's true, then we also know who must be before K. The only ones who are left. P, N, and G are going to occupy spots 1, 2, and 3, but I put them vertically because we do not know a thing about their relationship to each other. There are no lines connecting G to N or G to P or N to P. That can't help us here, but we've already got what we need for the answer by addressing who comes before and who comes after. Now this is a could question, often best done by elimination. If you look down the choices, you'll notice that several of the answers simply put a player on the wrong side of K. It's true of answer A, and C, and E. It leaves B and D, both of which have a player on the correct side of K. So how do we rule down further? Well, as always, consider limitation. At first glance, it might look like O could be the 5th valve, but don't forget, H is in front of it. So in fact, it cannot. If O were 5th, H would have nowhere to go because K is 4th. H would get squeezed out. Answer D is out. And the answer must be B. For our final conditional question, we'll go to number 7. And you want to note here, this one is phrased differently. It has an except, but it's must be true except. That's a little different than could be true except, because the opposite of must be true is actually could be false. Or to put it another way, the 4 wrong answer choices here must be true. Well, that could create an expectation in our minds, and rightly so, that we'll be able to come up with a lot of inferences here because we want to be able to lock in a lot of the players. They will correspond to the wrong answers, the things that in fact must be true. Let's take a look. If we do as they say and put G first and I third, we'll know that K is before I, as we've seen before, so that must go second. Our 8th position will tell us that L must be last, since I is not. But we maybe hit a little bit of a roadblock beyond that. Can we, in fact, lock in further players? Well, look at who remains. And we could even take a moment to draw kind of in the middle of our grid who does remain in their relationship. So we have PN before H, before O. Just going to kind of draw a box around that. That has to occupy these 4 positions. Do you see what's happening? H and O actually are locked in as well because they both must follow P and N. And H must go before O. There's nowhere else for them to go except spots 6 and 7. P and N have to go before H, but we don't know their order. So I'm going to put them in with what's called a handle. It's a little curvy line. Imagine grabbing it like a suitcase handle and turning it around. That tells us that P could go before N, but also N could go before P. If you prefer, you can use slashes there. Put P/N in one position and N/P in the other to indicate that interchangeability. Either way, we know that that's the only space where something is not completely known. Unsurprisingly, the right answer, B, trades on that very fact. N could be 4th, as B suggests, but that could be false because N could be 5th. If you look at the wrong answers here, you can note that all 4 of the wrong answers correspond to an inference we made locking somebody into position. K 2nd, H 6th, O 7th, and L 8th. By the way, I promise the right answer to logic games is not always B. I wish I could tell you that great hack, hey, just answer B 23 times in a row on logic games and you'll get a perfect score. But alas, it's just a strange accident of this game. All right, now let's go back to number 2, and then we'll hit number 5, our global questions, where we'll use the research that we have to answer questions about more globally what can be true. Number 2 is a good place to start because it focuses on that 5th position. Who could not be 5th is what the question is asking, right? Another could except, which means we could approach number 5 by saying, well, who could be 5th? We could list out players that we've seen as possibilities for 5th. Definitely includes H in a couple of our diagrams. It includes P, it includes N, and it includes I, if you look at spot number 6. Question number 6, I should say, because I can float around a lot of different places. I'm listing those that could be there, and that's going to lead to us knocking out choice A, which is H, choice B, which is I, and choice D, which is N. It only leaves choices C and E. Who couldn't be 5th? Well, we could pick one of those to try out, but if you remember well what happened with K on number 6, you may be a step ahead already. We already determined in our thoughts about number 6 that K has 4 players after it. So K cannot possibly be fifth because there's too many after it, and choice C is the answer. If need be, you can draw out an example that shows that O could be fifth. Technically, we probably could have done that with our diagram for number 3 if we filled it out some more. PNH. No, I guess it wouldn't work in that case. Our diagram for number 4, though, I think we could put O fifth. But you only need to draw that out if you haven't made the inferences we've seen already. By the way, I'm noticing I made that number 5. Sorry, that's number 2. We'll just right over that. Number 5, next to it, is if you had to skip a question on this particular game, this would probably be the one to skip because it gives you the least upfront information. So unless you've made an extremely concrete inference, like somebody's always in position number 3, this is one you could skip if you needed to for time purposes. When it asks simply what must be true, you can take what's often called the counterexample approach. Or in philosophy, it's referred to the white and black swans example. If somebody makes a claim that is universal, all swans must be white, we only need to show that person one black swan to disprove their universal statement. That's part of the kind of logical weakness of universal statements. They're easily falsified if you can find one counterexample. So I like to approach number 5 in that very way. I like to look at each choice and say, can I falsify it? Can I find an opposite to what it's saying? Let me illustrate with choice A. Can we say the opposite of at least one valve happening before P? Well, what's the opposite of at least one, you might say? None. The opposite of at least one is none. Could we have no valves before P? Well, certainly P could be first if we look at our web. So it doesn't have to be true that at least one valve is open before P. We have falsified it. We have found a counterexample. Similarly with B, we could say the opposite of at least 2 is either 1 or none. Could we have 1 or no valves before G? Sure. G could be first. So B is gone. Now we have to kind of flip the script for choices C, D, and E, because now the language is no more than. Well, the opposite of no more than is to take out the no. It's to say more than. So choice C, is it possible that more than 2 valves are opened after O? At first glance, it might appear not, but look carefully. After O, we definitely have L. We could have G. And don't forget about that I possibly floating to the right. L, G, and I could all be after O in certain circumstances. So C is gone. Choice D is actually surprisingly similar. Could it be true that more than 3 valves are opened after H? Well, we just take the same ones we already had, that could be after O, and add O into the picture, because O is after H. So 4 valves could be opened after H. D isn't necessarily true. The answer must be E. But let's try to find a counterexample just to prove that. No more than 4 valves are opened before N. So could more than 4 valves be opened before N? Well, you look at N and see all the ones that have to be after it, H, O, and L. At the maximum, we could do K, P, I, and G before N, but that's the most. No more than 4. We failed to disprove choice E. It indeed must always be true. Now to wrap up, admittedly, it takes a relatively long video to explain all of these choices. All of these questions, I should say. But it, of course, won't take you that long with practice because you won't be narrating it the entire time like I have. With loose sequencing, we've gone through the best way to set up the web, to think about the first and last, and then to order the questions and diagram them in such a way as to gradually and consistently increase your understanding of the game as you go through it. I like to think of my students as true experts on this particular scenario by the time they get through all the questions. Because not only have they thought about the relationships, but they've played out several very specific examples. So they're very much the masters of the possibilities for each of these 8 players. I hope this intro video has helped you think about not only loose sequencing, but many principles for doing logic games in general. We'll have other videos that address particular examples, particular games that come up on the prep tests, and also how to address other kinds of games like strict sequencing, in-out grouping, and grouping with sorting or distribution. So take a look at those as well. And go get them on logic games. You'll get faster and faster, better and better, and in the end, hopefully a deeply satisfying experience of really acing this section. Best of luck.